Welcome to today's webinar presented by Dlubal Software. Today we'll be giving an overview about our structural analysis and design software. The topic for today's presentation is Introduction to Dlubal Software for Structural Design. My name is Amy Heilig. I'll be your presenter. I'm the CEO of the US office and also a sales engineer, and I'm located in Philadelphia, Pennsylvania. My colleague Alex Bacon will be your moderator, answering any questions you may have. He's a support engineer also located in our Philadelphia office. We always want to encourage everyone to ask questions throughout this presentation. You can do so within the GoToWebinar dialog box as shown here. If by chance we don't get to all your questions or you have questions afterwards, you can certainly hear from us afterwards. We'll go ahead and send you an email to follow up on those questions. So we'll quickly go through the content that I do want to cover over the next hour today. We'll begin with a brief introduction to our company as company history before moving into our programs, including RFEM 6. So we'll talk a little bit more about which add-ons are available and the overview there, the licensing and interface benefits. Then we'll dive a little bit deeper into these add-ons specifically to talk about the capabilities and features. We'll then move on to our standalone programs, including an overview about RSECTION, as well as our CFD wind analysis program, our RWIND 3. And finally, I'll wrap up today with common challenges that you might have in your existing structural analysis program and how we as Dlubal Software hope to step in with solutions. And finally, at the end, we will talk about next steps. If you liked what you see in today's presentations and would like to follow up on any of our products, we'll let you know how to do so. So we'll begin now with a little bit more about the company and the history. So Dlubal Software was founded in 1987, so we're by no means new to the structural analysis and design software market. And we were founded by George Dlubal, again in 1987, but he still remains the owner today, very much involved in the development of our programs. His son, Daniel Dlubal, also pictured here, is our COO, poised to take over the company. So again, still remaining this family-owned business. Now, we do have many international offices. So we are headquartered in Germany, but several offices throughout Europe, as well as China and many other resellers around the world as well. But in the summer of 2015, we opened up our USA subsidiary office in Philadelphia. And as it stands now, our company has over 300 employees devoted entirely to the Dlubal program. So we're certainly not trying to balance hundreds of different programs, but really the structural engineering software is our main focus. And since establishing this office in 2015, we've been able to grow our customer database to over 250 offices throughout the US and Canada. So now moving on to RFEM 6. So this is going to be the flagship of the software that we offer. This is our general FEA program that will continue to dive into the details here for the structural analysis and design. So for those of you not familiar with our software, RFEM 6 is the base program. This allows us to fully integrate with BIM software, which we'll talk about in just a minute. We have access to all of the cross-section materials, all of the standard cross-sections and the materials directly in this base program where we can fully model the structure as well. If we're not using BIM integration, we can apply the loads and get a full static analysis. So for anything that is required, a more advanced analysis like dynamics, for example, or if we want to carry out the design according to the various standards, we would need these individual add-ons. So just to name a few, you can see these listed here. This isn't an exhaustive list, but we will dive into some of these in just a few minutes. But more or less, you create this software package that's specific for your design needs, anything beyond the general static analysis here. Now, we have a couple of standalone programs as well, RSECTION and RWIND. These we'll also touch on. They do integrate with RFEM 6. So we'll talk a few benefits here about the RFEM 6 licensing. So we still offer the ability to outright purchase your license. So a lot of companies have done away with this, only offering subscriptions, but we still offer this perpetual license option. You can choose to do a subscription, or you can even rent for a shorter duration of time, such as 1, 3, or 6 months. So as mentioned too, with this modular concept, this allows us to create this affordable software specific to your design needs. So you're not purchasing the capabilities that you don't necessarily use with your day-to-day design. We did move entirely to cloud licensing for this new version. So it's very easy to share the license between multiple users in the same company, or to access at home or at work. We also release a new program version every single Monday. So this is definitely different than a lot of those competitor programs out there. And the reason that we're doing this is because we're putting so much effort into these new features, developments, code updates, program fixes, that we want to make this accessible to you every single week. We also have a reliable support team located here in Philadelphia with our engineers, so they're able to answer any questions that you may have. But if you've ever visited our website, dlubal.com, you'll also find access to hundreds of free online webinars, technical articles, FAQs, and more. Again, not just for our existing customers, but also for anybody who's interested in testing out the program as well. So moving on now to BIM integration specific within RFEM 6. We do offer a bi-directional direct interface option. So we can import, export kind of round trip between the programs listed here, including Revit, AutoCAD, Tekla, Rhino, and Grasshopper. And the reason why I listed a direct interface is that these two programs are speaking directly to one another locally on your computer. We're not sharing some commonly shared file extension between the two programs to exchange data, but again, rather those two programs are directly exchanging data together locally on your computer. Now, we also offer some additional integration options with file imports such as IFC or step files might be quite common, as well as some export file options as well. We understand that the drafter and the engineer are working very closely together, that we're trying to increase the efficiency here with our design workflow while decreasing the modeling time. If that structure already exists in Revit, we want to bring that into RFEM with the materials, the cross sections already defined here, again, to decrease the overall time. So we also have an open API interface. This allows us to create our own apps or workflows for efficiency and customization. So you can create a programmable interface for RFEM 6 using this high performance gRPC technology. And we put a lot of development into this new API for RFEM 6 lately. This allows us to automate repetitive or time-consuming tasks. So for example, if we have the existing model data outside of the program, we can actually use this API to automate the modeling process, or we can use it to feed data into the program or to pull results out of the program. And ultimately, we connect the interfaces to these external tools. So maybe that is your own spreadsheets or in-house programs. It's a third-party program, or it can be even your own website for your company. Now, we put most of the development in based on Python language, but we also support C# as well. And if you visit our website, you'll find a lot of comprehensive documentation and examples available there on the open API capabilities. Now, as far as access to the API, we give you 1,000 free requests per month. If you plan to kind of go over that amount, then you have the option to choose kind of a subscription-based option with the API, either billed monthly or billed yearly. So let us move on now to the actual program within RFEM 6. And we have completely rewritten RFEM 6 from scratch several years ago. We didn't take an old version and just kind of build off this old interface and technology. So therefore, this allowed us to take this incredibly powerful nonlinear analysis program, but yet create this user interface that is user-friendly. We have a lot of CAD style modeling tools like snap points, drag and drop. You can mirror, you can extend lines or members. Again, a lot of those same tools that you'll find in AutoCAD. We also wanted to improve the analysis and design workflow, meaning we didn't want the analysis and design to be a two-part process between the base program and the add-ons, but rather you'll find one fluid workflow for that modeling, again, analysis and design workflow. The program also has a lot of default saved views. So meaning if we have an extremely large structure and we're trying to filter based on a particular member cross-section or a material, this is already built into the program, but you can always create your own user-defined saved views as well to quickly navigate to certain portions of the structure. Again, very useful for these larger structure types. All of the toolbars up at the top are adjustable or customizable, meaning you can add additional tools or buttons you can rearrange. You can even assign some of these tasks to your hotkeys directly on your keyboard. The user interface is also customizable. So we can adjust font sizes, we can change colors, whether that's for the elements themselves or fonts. We can modify the sizes, again, not just for text, but let's say an arrow size can be modified. So a lot of control over this as well. And finally, we do utilize the gaming graphics card on your computer, so such as NVIDIA or AMD, to create these high-end graphical 3D outputs. So not only graphically within the program, but also generating these images for our calculation report. And all of the images that are used in today's PowerPoint come directly from our program. So this should give you an idea of how high-end the visuals are. So turning now to the specific add-ons, we'll start with the steel design add-on. So again, integrated within the base program RFEM 6, this allows us to take the analysis results and carry out both the hot rolled and cold form steel design of members according to the USA and Canadian standards. So we'll start off with hot rolled steel design in particular, and this does include the AISC 360 that you see here, as well as the CSA S16 and other international standards. So you have access to all codes when you do purchase this add-on. Now, we also have updated the intelligent effective length member input. So we can automatically detect nodes that are framing into a member. And this all comes into play for topics like unbraced lengths that will be used in the design workflow. So again, kind of that intelligence there to detect where members are framing in and use that within the design itself. We have an eigenvalue solver for the lateral torsional buckling critical moment capacity, and we would want to use this in scenarios where maybe the code doesn't necessarily address lateral torsional buckling. For example, members that are not in a single plane that we see over here on the right-hand side. The code doesn't necessarily address that, so we can activate this eigenvalue solver for LTB, and we'll determine the critical moment capacity from this separate calculation. Now, alternatively, if you do just have a simple member and you want to design according to Chapter F from the AISC for LTB, this is also possible. You'll hear me say this over and over again, that all of our design add-ons, including the steel design, come with complete design output, including the formulas, the variables, and the code references. So the complete opposite of a black box, we're trying to be as transparent as possible about where all of this information is coming from, so you as a user have access to that. We also have additional AISC 341 seismic checks for our members. We'll continue to expand on that in the future as well. And we're about to release in the next couple of weeks the CSA seismic design checks as well. Now, not only do we have access to the cross sections in the main program and materials, but we can always create our own custom cross sections, either with the parametric sections, or we can integrate with our standalone program RSECTION for full member design as well. Built up sections is another topic that, again, we can carry out the full steel design for, including local buckling checks. Moving on to cold form steel design, this includes the AISI and the CSA S136 standards. We have the ability here to design those cross sections that you find from these codes, but it's quite common to also have custom cross sections. So you might find the parametric sections directly in RFEM that are available. We have a good handful there. or again, integrating from our section for much more complex custom cross sections. I will mention this here and a few more times as well. The really powerful thing when we're talking about cold form steel or ADM aluminum sections is the ability to also design these members but check local buckling. So not all competitor programs are able to do that. Now, specific to cold form steel design and buckling, we have implemented the direct strength method. And this gives us a little bit more accurate buckling strength predictions versus a little bit more antiquated approach with the effective width method. So again, utilizing direct strength method. Now, within this, we also utilize the finite strip method for section buckling mode curves. So for every cross section, whether it is from the standard or it's a custom cross section, you can see over here on the right hand side that with the finite strip method, we will display the local distortional and global buckling curves. You can even see the distorted shape here as well given, and we come up with the total curve, which is ultimately used in the design workflow according to these standards. Now, a very common question is, do we have cold form shear walls? This is something that is planned for the future. Currently, within the cold form steel, it's a little bit more specialized for member design specifically, but we certainly will keep that in mind for cold form shear wall design in the near future. On a related topic, we have our steel connection design. And this is certainly a bit more unique than a lot of the connection design programs out there. And the main reason is because we utilize the component-based finite element method. So for every connection, we are building up an FEA model underneath the hood. And why this is powerful is because this gives us the ability to design any connection. We're not just limited to the standard beam to column to brace. The AISC 360 is available. The CSA S16 is currently in development. We hope to release that towards the end of the year. So a couple more points to touch on here that set us apart from the other connection design programs is that you can carry out the full member design and the connection design in one file. So we no longer have to export out these member end forces. You can imagine that we have less data loss, or if we need to update the model, we're not having to re-export out those member end forces each time. Everything is working seamlessly together. We do have a predefined library for a lot of common connection types that you can choose from, or you can build up your own with the individual components and save that to your user-defined library for future RFEM models. And we'll take a look at that on the next slide in just a minute. Full base plate design is also included with the ACI design checks for that foundation block. Another unique point is that we can fully calculate the stiffness of this connection. So with connections, they're typically not fully pinned and not fully rigid, but somewhere in between. So the steel joints add-on will calculate this stiffness for us. And with the click of a button, we can actually export out this stiffness to the member end condition. So therefore, when we're designing our member, we're taking into account the true stiffness of the connection with that K value, rather than, again, considering it fully thinned or fully rigid, but again, taking into account the calculation that has from the steel joints with that stiffness. If we pair this with the stability analysis add-on, we can take this a step further and take a look at the buckling checks of the connection. So we can view these plate elements that would be prone to buckling, including the critical load factors, which would help us determine where maybe we need to add in additional stiffener plates. So on this next slide here, I just wanted to point out the broad capabilities of the steel joints add-on. So if we do have a standard connection like a beam to a column, this is certainly possible, and you'll find this in the library. But if we have a much more unique scenario, such as this one to the left or a larger picture here, this is also possible. And for the design, again, we build up this FEA model underneath the hood automatically. We check the bolts and the welds according to the AISC standard, and all plate elements are checked compared to the limiting strain value set. Moving forward to the concrete design add-on. So this allows us to carry out the reinforced concrete design from everything from beams and columns to walls and slabs. The ACI 318 and the CSA A23 are fully implemented here, as well as other international standards that we offer. So as mentioned, we can input in the reinforcement and get full design according to these codes for beams and columns. If we do have a column, the column 3D interaction diagram, as you see here on this slide, will be available to you as well. We can also carry out the reinforcement design of plate and slab elements. So this could be a slab on grade, for example, with a spring support underneath it. It could be an elevated slab or a general wall element. And we have two methods when it comes to something like slab design, either the FEA approach, where we will provide ISO lines of required reinforcement versus the provided reinforcement, or we have recently implemented as well the design strip method. So this is a little bit more common in North America. We can generate the design strips automatically according to those standards. And one thing worth mentioning here is that with the design strip methods, we're not only looking at the bending moments in a one-way direction of the design strip itself, but we also have the ability to consider that twisting or torsional moment within the design strip. Not all competitors are able to do that. It's a much more simplified approach, but we're also able to consider what we call the MXY moment of that surface element. Punching shear checks are available at column and wall intersections. Now, as mentioned, you can carry out the design of a slab on grade, but we are working on a foundation-specific add-on for these standards. First to be released will be isolated footings according to the ACI and CSA standards, and then we'll continue to add additional foundation types for those particular codes as well in the future. PT design, this is also in development. Currently, we have a beta version of a tendons add-on to define those pre-stressing tendons. Eventually, we will link that up to the concrete design add-on as well to get full PT design. So now we have timber design. So we're kind of moving a little bit more into maybe the capabilities that are not available in all structural analysis programs. So we have the ability to design everything from stick frame structures clear up to multi-level story mass timber structures. The NDS and CSA 086 are included, as well as any other standard that we offer, where we will carry out the full strength, serviceability, and fire design of both members and CLT surfaces. And the fire design is a bit unique in that we can actually reduce the cross sections of our members or our CLT panels based on the fire exposure time. We automatically export out those reduced cross sections back to the global model, and we rerun the analysis with these reduced stiffnesses because inevitably we have new internal forces. We then compare those new internal forces to the fire design equations directly from the standards to give us a design ratio. This is entirely separate from the strength and serviceability checks with the full cross section. So pretty powerful in the sense that we're able to actually reduce the stiffnesses there within the fire design checks. Now the member design, yes, this includes all access to solid sawn, standard timber members. Again, all of those materials and cross sections are available in the main program, but we can also do glue lambs, including tapered glue lambs, curved glue lambs. We will check radial stresses according to the standards so we can get into these more complex scenarios. So in order to define the CLT layup, so cross-laminated timber, we do need the multi-layer surfaces add-on. So this is kind of paired with the timber design add-on. You have access in this add-on to all of the manufacturers that produce CLT in both the United States and Canada. So it's very easy to select an existing product from this manufacturer, or you can create your own custom CLT layup as well, individually defining these layers oriented at 90 degrees. And when we carry out the design of the CLT panels in the Timber Design add-on, we will actually see the stresses in each individual layer as well as the design ratio. So we compare those stresses to the code to give you the panel design ratio. Some common questions: yes, we check rolling shear. We give you the design ratio for this. Point supported CLT panels or panels with openings. This is all possible in the program. Now, as far as timber shear walls, it's currently possible in RFEM, again with that multi-layer surfaces add-on, to define what we call a timber beam panel, where you can specify the sheeting, whether that's OSB or plywood, the stud spacing, and we can even specify the nailing layout and calculate the true connection stiffness between the studs and the sheathing. So this is available within RFEM now. Now the design is currently in development. So we plan to release that in the next coming months to, again, give us that design ratio according to the NDS and CSA standards. So we're almost there with that. But in terms of modeling those elements and taking into account the stiffness in the analysis model, this is possible at the current time. Timber connection design, this is also something that's in development. We will have a new add-on called timber joints, kind of following the same workflows like our steel joints, where we will build up an FEA model underneath the hood, but taking into account both the timber and those steel elements. Aluminum design is also possible in the program. So we can carry out the member design, not only of those standard sections, but custom extrusions is a very big topic when it comes to aluminum. So we currently have the ADM standard available and have for quite some time. We're also in works as we speak with the CSA S157. So we want to release that within the coming months as well for full member design according to the Canadian standard. This does include the strength and serviceability design checks for all of our standard shapes that we find within the ADM. But similar to cold form steel, we can get design of the parametric sections, again, a handful offered within RFEM, or we can utilize RSECTION. And I'll get into the details of RSECTION in a few minutes, but essentially I can bring in this custom extruded shape like what we see over here on the right-hand side, and I can get full member design according to the ADM. But not only this, you heard me say this with cold form steel, we can also get the local buckling checks. Again, something that's very unique with the RSECTION to RFEM integration is being able to also get the buckling checks for these particular unique members. Now, as far as local buckling methods offered within the ADM, we offer all three, including weighted average, direct strength, or limiting element. So the next very niche add-on is glass design. And I place this after aluminum because these tend to go hand in hand, where we can use this glass design add-on to design single glass panels or entire glass systems. So as you see here, there are glass stairs. Again, being able to model and design everything from a single panel to these more large structures. In the current state in RFEM 6, we allow you to define here either single layer or laminated glass panels. So you can define those different layers of the laminated glass panels. You can specify the shear coupling between those layers is either rigid or free. We see the full stiffness matrix available to us. Now, insulated glass panels. We previously had this in our older version, RFEM 5, but we wanted to do some updates and modifications just to better this analysis and design for IGU panels in RFEM 6. So it's not quite ready, but we plan to release that towards the end of this year. And that will be integrated directly within the glass design add-on. But what is new in RFEM 6 is the ASTM E1300. So we previously did not have this in our older version, but now you can carry out the design checks of these glass panels according to this US standard. So as mentioned, we can go ahead and carry out the design with a single panel. It can also be a curved glass panel, but the powerful thing is modeling the entire system in RFEM together. So something like a facade wall or glass railings, or we saw on the previous slide, glass stairs, and being able to fully carry out the member design with the glass design. So when we're talking about something like a facade wall, we have the ability here to design those custom aluminum extrusions with this facade wall. I see this example shown over here on the right-hand side, but also the glass panels in a single model. We can even specify too with how these models are connecting to the members themselves. So if we don't want a fully rigid connection, we have the ability to release moment or to allow some type of slip depending on that silicone connection joint at these locations. So a lot of capabilities there, but the important point is that again, we can do the full design of the supporting structure along with the glass panels. So another niche market that we offer is the form finding analysis. So this allows us to determine the catenary shapes for cables and for fabric membranes. So within RFEM, we have the ability to model a cable element as a completely straight member, or we can model a fabric membrane as a flat surface, as a standard surface. And once we input in this form finding load, this pre-stress load, the program automatically calculates the best shape for us, this catenary shape. So we don't have to model this manually within RFEM. Now, when we activate this add-on, we have a few different loads available to us specific to the form finding process. So you as a user would go into either these cables or these fabric membranes and set the target geometric loading, such as a target sag or a target length. You can also alternatively specify the target force loading, such as the pre-stress force or the tension or the force density. So both of those are possible with those elements. Now, not only can we do fabric tensile structures, but also pneumatic air-supported membrane structures, such as you see over here on the right-hand side, are also possible with this add-on. And again, emphasizing that this add-on is not just specific to the fabric membranes, for example, but we can pair this with the steel design add-on to get the supporting structure design. So it's quite common with these fabric membranes that we have steel members as well. So being able to carry out the full steel member design according to the AISC or the CSA standards, and not having to use a specialty program for the fabric, manually transferring these forces into another program that carries out the steel design, but everything is carried out together. Moving on to dynamic analysis. So we have several different add-ons depending on the dynamic analysis need. So everything from seismic forces to forced vibrations. So we begin with our first add-on, the modal analysis. And this will take our structure and carry out this eigenvalue analysis to determine the natural periods, frequencies, and mode shapes, accelerations. This add-on is always a prerequisite before we can utilize any of the other dynamic add-ons listed here. So if we are interested in carrying out a seismic load generation, we would want to utilize the response spectrum analysis add-on. So within this add-on for seismic loads, we do have the codes implemented here, the ASCE 7, the NBC standard. And with the response spectrum analysis, this is applicable to any structure type. And that's why we've taken this approach with the response spectrum. Because not only is this a building program, but again, we can do these fabric tensile structures, we can do domes, we can do any type of structure which a response spectrum is applicable. Now, with that said, we certainly have had a high request for more simplified building structures and the equivalent lateral force procedure. This is something that we will also implement in the future, and development with that has already begun. We have our third dynamic add-on, the time history analysis, and this is for external excitation. So we have the ability here to define this force time function, or it can be user defined, or we can choose from an accelerogram library if we would like to replicate this seismic load on our structure. And once we've carried out this time history analysis, we can view the structure response with what we call these calculation diagrams. And I'll go ahead and jump to the next slide quickly just to take a look at this. So something like a pedestrian bridge, for example, this was done to emulate somebody walking across this structure. Well, we can always view the response at other parts of the structure, so a particular node or a particular member. Maybe we want to look at the deformations over time, the accelerations. You can create multiple calculation diagrams for this time history analysis and the result output. And finally, we have our pushover analysis add-on. This is currently according to the N2 method, but we also recognize that something like the capacity spectrum method is heavily utilized with something like pushover. So we will plan to add that in the future as well. Then we have our building model add-on, and this is new within RFEM 6. So keep in mind that I have already mentioned RFEM 6 is a general FEA program. We are not limited to just buildings, but really anything is possible. But with that said, we have developed this building model add-on to be more competitive with those building-specific programs out there, but again, all in the same program. So now when we enable this add-on, we have the ability to define stories in this general FEA program. Otherwise, the program doesn't really recognize what a story or a floor is. This also releases these multi-story modeling tools. So for example, if I have a column at the same location at every story, at the click of a button, I'm able to place that column continuously. Whereas without these multi-story modeling tools, I would have to manually replicate that column at each story level. This also releases our diaphragms. So within the building model add-on, we can specify rigid, semi-rigid, and flexible diaphragms. I will jump to this next slide quickly just to speak a little bit more about the diaphragms and the stiffnesses that we offer. So again, we have these various diaphragm types. When we have defined these different stories and specified a rigid or semi-rigid diaphragm that you see here, we actually separate out the analysis into two separate calculations, the gravity versus the lateral. So with this, we will extract out the floor elements and only apply those gravity loads. And as far as the stiffness, we'll actually use the true stiffness of the material, of the thickness that's been defined for that floor. But when we look at the lateral calculation, we will modify the stiffness of those floors. So for rigid, we'll use an infinitely rigid stiffness in the in-plane direction, but out of plane will be set to 0. Semi-rigid, out of plane is also set to 0, but the in-plane is set to the actual stiffness. Now, when we use a flexible diaphragm or we don't define any diaphragm at all, we are going to carry out just one analysis calculation like we would with a general FEA model, lateral and gravity together using the relevant stiffnesses defined here. Now, with the result output, when we have enabled the building model add-on, we do get some very user-friendly table options in the sense that at every story, I can now view information like center of mass, center of rigidity. I can view story drift and story shear, which might be really important for seismic analysis. Again, just kind of putting that in a little bit more user-friendly format for each individual story level. When we also pair this with the concrete design add-on, we are going to get additional design checks for shear walls. So referencing the ACI specifically, Chapter 11, we will carry out additional design checks for that reinforcement design of shear walls specifically to that chapter, as well as spandrels, otherwise known as deep beams in our program. We can also design those when these two add-ons are integrated together. And our final add-on within RFEM 6 is my favorite, the stability analysis. So this will actually carry out the buckling behavior of slender elements. So if we have very slender members in our models or very thin-walled surfaces or even solids, we can take each one of the load cases or the load combinations and additionally carry out this stability analysis to determine the flexural buckling failure modes. And we get a graphical display of the failure mode shape directly within RFEM, again, for each one of these load cases or load combinations. And depending on how many eigenvalues we solve for, we can see the relevant mode shape, but we also get the associated critical load factors. So what's the factor that I can multiply by my applied loads before I see my structure or my elements fail with that relevant buckling mode shape? We can take this information too and integrate it in other parts of the program. So for example, member or surface imperfections. I could take my buckling mode shape of a surface element and I could scale it. And I could actually deform the FE mesh of that surface element before I carry out a general static analysis. Or we could import in these critical load factors as effective length factors for our steel design. So a lot of different options there, again, extending to other parts of the program. Now we can activate here an additional add-on called torsional warping 7 degrees of freedom. So this now activates this 7th degree of freedom in the analysis, no longer 6 degrees of freedom. And when we carry out the stability analysis now, we're actually also going to see these lateral torsional buckling failure modes, as you see over here on the right-hand side, this sort of twisting. So when we are confined here with 6 degrees of freedom, we're only going to get these flexural buckling failure modes. But when we enable the 7th degree of freedom here, we will also be able to view the lateral torsional buckling failure modes. And the final point here is that this add-on can be used to troubleshoot instabilities. Instabilities are not specific to RFEM. They happen in every FEA program. And the question is, does your software have the tools to help you address these? Because they can be very, very frustrating. Well, this particular add-on will help you determine exactly where the problem is. So for example, if two nodes are not connected together, this will point you directly to that location. Or if your structure just simply can't handle the applied loads under a second order analysis, it will also kind of direct you to where this error occurs. So really powerful in the sense of helping us troubleshoot instabilities independent of kind of the buckling behavior of our structure as well. So now we'll move away from RFEM and into a couple of our standalone programs. So you have heard me mention our RSECTION program. This helps us calculate the properties of these custom cross sections. And within this standalone program, we have the ability to calculate either for thin-walled elements or an FEA analysis type. So both options are offered for thin-walled cross sections or for more massive type sections like concrete. If you want to create your cross sections, so for example, built up cross sections, you have access to all the same cross sections materials that you do in RFEM. So an extensive library of these rolled, parametric, thin-walled, or even massive cross sections. But you can also import in something like a DXF file, which is again quite common for an aluminum extrusion. Now, when we are calculating according to the thin-walled analysis, we will further generate these elements on the cross section. And these elements is what provides the information that for each one of these element parts to our cross section, we know the width, we know the thickness, we know if it's supported at one end or both ends. And that way, when we bring this into RFEM to carry out the full design, this is why we're able to carry out the local buckling check. So for example, ADM, we refer to Chapter B because we have all this information directly from our section. Also for massive sections, you can go ahead and define the custom reinforcement layout. So we may have a very complex massive section here. You have the ability to define both the shear and the longitudinal reinforcement. And this way, when you bring this cross section into RFEM, we can also carry out the design here of the concrete member according to the ACI and CSA standards as well. So really seamless integration between this standalone program and RFEM 6. That's the entire point here. We get also a nice rendered view of this cross-section once we are in RFEM. It's not a standard line element or any type of general cross-section, but we'll actually see the true rendered section as well as the full design. Moving on now to RWIND 3. So this is our CFD wind analysis program where we utilize a numerical wind tunnel. So for those of you not familiar with CFD, this is computational fluid dynamic analysis, where essentially we take our structure, we put it into this numerical wind tunnel to determine what these wind pressures are. Now, RWIND can certainly be used as a standalone. We have architects, for example, taking advantage of this. It's not necessarily just for the structural engineer where you could import in an IFC file, because all that we need is the geometry here to determine what these wind pressures are. But the powerful thing is integrating, of course, with RFEM 6. So we can automatically send our structure from RFEM 6 into RWIND, calculate the wind pressures, and then bring the wind pressure information back into RFEM 6. So when you are integrating with RFEM 6, we also have the ability here to automatically generate the wind profile according to the codes such as the ASCE 7 and MBC. And this is not to be confused. CFD is entirely code independent. But what I mean by this is the wind velocity entering into the wind tunnel can be generated according to these codes, taking into account some of the different coefficients. So what is the wind speed as a function of the tunnel height? We have the ability to consider adjacent objects. So if we're in a very dense area with buildings that are very close, this is inevitably going to affect our wind flow on our structure. So we can not only take our RFEM 6 model, but also import in IFC objects to represent those adjacent objects that will, again, affect that wind flow. Or complex terrain can also be considered, such as hills. Doesn't necessarily have to be on the flat ground, but kind of considering those more complex conditions. Now, once we run the calculation in RWIND, again, we determine the wind pressures, the wind pressure coefficients, velocity vectors. You see the streamlines here on this particular slide. But ultimately, when we close out of RWIND and back into RFEM 6, these loads are automatically taken, the wind pressures, and converted to static wind loads on every FE mesh element. That way we can then combine with the other load cases like live load, snow load, and continue on with our analysis and design. So we might be wondering, well, why would we want to use a program like RWIND 3? So I wanted to go through a few advantages here. You can imagine that this can be a really powerful tool for a wind analysis very, very early on in the design stages. So if we're kind of toying around with the different geometries, or we get this information from the architect and we're interested to know what the wind loads are very early on, it's very quick and efficient to just put it into this numerical wind tunnel. We also can use this program to determine occupant comfort, or again, as I mentioned on the previous slide, to consider surrounding objects or complex terrains. Now, ultimately, if your project does require a true wind tunnel test, and there's no way around that, this tool can also be used. So you can put your structure into this numerical wind tunnel, adjust the design before we're spending the time and the money to carry out the true wind tunnel test to determine that our design is not adequate. So being able to make those modifications, again, very early on. So ultimately, we recommend something like RWIND for structures that are completely outside the standard minimum guidelines that are given from the ASCE 7 or the NBC. We would never recommend this program for a box type structure. The code is very clear on how to apply wind loads there. You could use the automatic wind load generator directly within RFEM 6 according to those codes. But when we have complex geometries that the code really does not touch upon, so we see this used a lot with fabric tensile structures, or maybe buildings that have a lot of reentrant corners or adjacent objects. Again, this just allows us to dive a little bit deeper into the wind analysis and to provide us a tool to double check our guesses and our estimations. And all in all, this program can be used for any structure type. It's not buildings, but really anything is possible, any shape and any wind direction, because we have the ability to rotate that wind tunnel as well. Okay, in the final 10 minutes here, we want to talk about some common challenges that you may be experiencing in your current structural analysis software, and where we hope that Dlubal may be a better solution. So we'll begin with first the topic of lack of program development. So a very common complaint that I hear is that my current program's interface is clunky, it's old, and it's outdated. The technology is just really not there anymore. So as I mentioned, RFEM 6 and also our other standalone programs were completely rebuilt from the ground up. So we chose a modern programming language with, of course, this cutting edge technology. And this is what has allowed us to produce these very high quality graphics, a user-friendly interface. Our calculation report is extremely powerful. We can also, this brings me to my last point, output these transparent, traceable results. So in older programs, we're just kind of finding a design ratio and that's it. So we're very much moving away from these black box software to provide you as the user with as much information as possible. So again, just implementing this latest technology here has allowed us to do so. And I'll jump to this next slide quickly to show you an example of the output. So in all of our design add-ons, whether it's concrete, steel, timber, aluminum, whatever it may be, we get the design checks on both members and surfaces. And with these design checks, we can pull open what we call the design check details, where you can see the formulas, the code references, and the variables listed here line by line, and ultimately how we have calculated this design ratio. So again, trying to be transparent with that information here that is available within all of these design add-ons. The other related challenge I hear is I'm paying these high fees each year and seeing very little in return. So you might be left wondering, okay, I'm paying these subscription fees or maintenance fees, and I get 1 or 2 releases per year, but I really don't see anything new in the program. So as mentioned, we are coming out with a new release every single Monday for our programs. You don't have to update every Monday, but that option is there for you for our programs. And as mentioned way back when at the beginning of this presentation, that's because we're just constantly adding new features, new improvements. We're listening to our customers' feedback, trying to better the program. When new codes are released, we're working as quickly as possible to get those into the program. And also it allows us to provide quick fixes for program issues. I mean, these are inevitable no matter what program you're using, but the question is, are you waiting 8 months for the next program release to see that fix addressed? Or within our programs, are you waiting a week because we're able to quickly get that fixed, and then maybe the following week you update and have access to that fix for your issue? The next topic is purchase and usage restrictions. So again, another challenge here is my software has moved to a subscription-only model. Our philosophy on this is that we still will offer the perpetual license option, and we plan to do this indefinitely. So you can spend this one-time fee and outright own your license. Now, alternatively, if you prefer to rent for 1, 3, 6, or even that 12 months, that's also possible. Or you can mix and match. So you can outright purchase RFEM and maybe the add-ons you use on a daily basis, but maybe a one-off project comes up that you can rent an add-on such as glass design for 3 months for a project that you know won't come up too often. Now, with that said, we also, I will mention, do have a maintenance contract that will renew every year, but those fees are very low. And again, hopefully you find the value in the updates. You're seeing where those maintenance fees are going toward. The other challenge related to this topic is my current program license is tied to a single computer. So this might be a little bit more antiquated licensing system. In our programs in this new version, we did move to a very flexible cloud licensing. So you can access this RFEM or RSECTION or RWIND license from anywhere, whether you're at home or you're at work. You can also share these licenses company-wide where everyone has their own login credentials, their email and their password. Now, only one person can be in the license at a time, but once it's closed out, it's checked back into the company for somebody else to use. It could also be the scenario where you have a few different RFEM licenses, but different add-ons on those licenses. So as long as that license isn't in use, you can easily toggle to it directly within RFEM 6 through the license manager, which is instantaneous. So you can directly switch to that license with the add-ons that are needed. The next topic is multiple program requirements. So the challenge here is my current software setup requires separate programs for gravity versus lateral versus foundations versus connections. And our philosophy here is to provide this all-in-one solution with these ability to add the particular add-ons that you need for your design. So ultimately, this all-in-one solution provides us with far less data loss, higher efficiency, rather than kind of bouncing around between all these different programs. A good example of this is steel member design with the connection design in one file. Also these niche markets. So you're not having to find these specialty programs for topics like mass timber and CLT or glass design or fabric tensile, but these are just additional add-ons that you can enable in your license along with the general steel and concrete design. And ultimately, you can imagine that this is very cost effective. So if you choose to outright purchase your one RFEM license, yes, there is an upfront cost, but we compare this to the fees 5 years down the road where you have been renewing these yearly subscription for multiple programs in order to just maintain access to the program itself. Well, then ultimately we find this far more cost effective. The lack of learning resources. So I can never find learning resources or quick answers to my questions. Again, I would encourage everyone to visit our website, dlubal.com, where you do have access to these free resources, whether it's webinars or tutorials, not only for new users, but for very advanced users as well. You can download example models that we have and open in your RFEM license. So we're very technology focused as well with AI, unrelated to maybe our topic here, but we're always looking to integrate more AI features in the program, especially in the future. But right now we do have our integrated AI assistant, Mia. She's shown here on this particular slide. She's available on our website, but also directly within RFEM, so that if you have a quick question, you can just go ahead and use that assistant there to find the answer for these questions. Now, if neither of these is working for you and you'd like to contact our support team in Philadelphia, of course, we're always here for you, whether you're testing out the program or you're an existing customer. And finally, we do offer custom online or in-person training if that is applicable. The final slide here is just cost versus value. And this kind of is a challenge maybe against us as Dlubal, that I'm very interested in the Dlubal programs, but they seem expensive, especially in comparison to my annual subscription that I'm paying now for my software. And again, I think we have to individually look at each one of these points, including the long-term value. If you have a perpetual license and you have this one-time fee for RFEM 6, we compare these to the repeated subscription costs, again, just to maintain access to your program compared to that one-time cost. So just keeping that in mind that we still offer that perpetual license. The modular pricing, you can, again, kind of scale this license and only pay for the features that you use. If you're somebody that never does glass design, you would never purchase the glass design add-on. But if a glass design project does come up, and maybe it's just a one-off, you have the ability here to rent add-ons as your project needs change. And ultimately, again, I'd always just encourage you to look at, your maintenance fees, your subscription fees. Where is this money going to? Are you seeing the development that you like for your programs? Emphasizing here that with RFEM, we're putting so much development into new features and updates within all the programs, especially within RFEM 6. And over 200 developers or coders devoted entirely to our programs. Okay, so we'll go ahead and wrap up today. If you did like what you see with some of the topics that we discussed today, I know this is quite a lot of information, but anything sparked your interest, would love to chat with you. You can contact our sales team using the QR code here or visit our website, or our contact information is shown at the bottom of our screen to our Philadelphia office. The email is info-us@dlubal.com. So as most of you know, we are celebrating our 10-year anniversary with a very big promotion this month for 30% off all of our products. This is all software, whether you're an existing customer or a new customer. This is valid for you until September 30th. So we don't plan to offer this pretty big promotion again in the foreseeable future. So if you are interested in that, certainly reach out to us and we'll be happy to discuss that further. We will have many more upcoming webinars, about once a month. You can register at dlubal.com under support, training, and webinars. As most of you know, I tend to send out a reminder email before these come up, so you can feel free to register directly through email. Now, PDH certificates will automatically be emailed to all participants who are here for the full presentation. So that is a requirement of the states that we are pre-approved providers, that you are here for the full duration of this presentation in order to receive that PDH. Now, if you watched with a colleague or in a conference type setting and you yourself did not register under the go-to webinar, you will need to request the PDH to our email address shown here, info-us@dlubal.com. So just let us know who you watched it with and ensure you were here for the full duration, and we'll be happy to issue that PDH certificate to you. And with that said, I want to thank everyone for attending, and as always, we hope to see you at our next webinar. Thank you.